In this video, I'll be talking about my plasma speaker project. I'll be showing you some of the fault finding and how I fixed some of the problems. I will also show you some of the diagrams that I found useful. But before I started on the project, I had to build my own soldering iron because my old one broke. If you want to see how I did it, let me know in the comments.
Anything you choose to copy from this video is at your own risk.
So how does a plasma speaker actually work? Well, to start off with, we're going to talk about the power section to the diagram. We've got a mains transformer, which has our live neutral nerve coming in, and then we've got the rectifiers, so we basically have two sides to the transformer. One side for the arc itself, 24 volts, both sides. The other side is to power the audio amplification circuit, so the two audio amplifiers. So we've got capacitors on each one, so we have a nice DC. I have a GDT. I don't think I really need that, to be fair. And then, so that's doing the arc, 24 volts to the arc. And then for the top side, we've got 12 volts out through a voltage divider. That goes to one of the amplifiers that powers. And then I've got an LM317T, and that's powering 16 volts out to the other amplifier. And then we've got a buck converter, which powers 5 volts for the Bluetooth speaker board, which gives us the audio signal. So that's it's not actually that complex, it's just basically just a big power supply. And then we've got the audio signal comes in to the LM358, and that's just like a preamp. So that's giving us amplifying the signal from 12 volts, and then we're putting that signal, after that's been amplified through these transistors, we're going through into a TDA2030 amplifier. That's a power amp, that chip, so that should be that's quite powerful in the output. And the reason we're doing this is so we can get the voltage up, so then I can switch a MOSFET from the output. And then here's the stage that really seems to matter. I have a high power MOSFET, which I've put in a position so I can change it easily, because that's going to break at some point along the lines of testing. We've got a diode, and then we've got the rotary switch, so that's going between the drain and the gate. So we've got the rotary switch with the resistances on, change the resistances, and that gives you a different amount of feedback. And then we've got a 10k pull down resistor, and then that just goes out to the load basically. And the load is of course the two Royer circuits, so it's switching the negative side, it's switching the ground at the frequency of the audio. So we've got the two Royer circuits, and then we've got two flyback stats, which the high voltage output side is just put in series with each other. So one side just goes straight out to the arc, and then the other side, that one goes down into the next transformer, secondary, and then it goes into a really big resistor bank to limit the current, which is really important, because if you don't limit the current, that's essentially a short circuit through the air, so it's going to draw loads of current, as much current as it can, and it's going to make your poor MOSFET get seriously hot, and it's going to make your transistors get seriously hot too. So I found that adding this resistor bank really helped. And then it goes from the resistors to the strobes, which is safer, because also if we have the resistor bank, it will limit the current. So if you was to touch it, which really would not be a good idea, you'd be a bit better off, because it wouldn't be quite so much current. So that's the whole circuit diagram. So basically all this circuit is actually doing is creating a really high voltage arc, which is oscillating at a frequency higher than we can hear, and then it's switching that arc at a frequency which is sound, the music, which is a lower frequency which we can hear. So then when it arcs, all you hear is the music. So originally I had loads of bipolar junction transistors all in parallel. This is the version 1 design, and they would switch the Royer circuits at the frequency of the sound again that we want to hear, and they were getting really, really hot, all these transistors, and then occasionally you would get one of them burn out and go completely closed circuit. And then I found that a lot of the time, well, obviously once that's happened, the arc would continuously stay on, and then audio would become really quiet, and eventually it would completely go dead, and it would just be a solid arc because it's completely completely closed circuit. So this was a complete failure, this design, really, although it worked really well. But I think if I had my resistor bank, it would have taken some of the load, and I think it might have lasted a bit longer. So in the very beginning, when I was making the plasma speaker, or when I was trying to design one to work effectively, I was using a ZVS circuit to power the flyback, and of course I had two MOSFETs, and the MOSFETs I found would get so hot I could put them under water and they would boil underwater. So I really had some stuff wrong there. I think part of the reason why the MOSFETs were getting so hot on the original ZVS circuits was because MOSFETs don't like to work in linear mode, which is where they're between on and off. The MOSFETs were being switched. I think they weren't fully saturating before I dumped loads of current through them, and I think that's why they were getting so hot, because they were almost permanently in linear mode. They were never really fully turning on, which you could probably achieve making that work with some MOSFET drivers, but I didn't have any at the time, and I've never really used them, so I just kind of decided to move on to a Royer oscillator circuit, and then it still continued to have the same problem. So then I came up with some really wacky ideas that I did test and experiment with to see if I could make something that was better, because this circuit didn't work and I got completely stuck because I couldn't make anything reliable. It worked well, and when it was working, but it would self-destruct very easily, even though each one of these was a 15 amp transistor. It would self-destruct so easily. So I tested some crazy ideas. I thought, what if I did the switching on the high voltage side? And I did make that work, but it sounded awful. A problem I had with the high voltage side is it would arc between the wires straight through the insulation, so I had to find something with a thicker rubber coating, and I found this plant wire seems to work really well. You can see how thick the rubber coating is there. And then I found, for insulating the ends where the rubber is no longer there, obviously because you're soldering it, you can't solder the steel very easily. You have to have RX flux solder on this wire. That's a problem with it. But you can use hot glue, and hot glue works really well as an insulator on the high voltage. I'm not sure if that's the actual thing that other people do, but I find it works really well for insulating it.
can't touch this.
So I was testing this off camera and some smoke came from either that potentiometer, that board or that board, the Bluetooth or the buck converter. I'm not really sure what the smoke came from and it stopped working. It wasn't much, but this it still seems to work a little bit and like on and off. This works on and off. So I'm wondering if the voltage dividers aren't delivering enough current. I wonder if one of the resistors on here smoked, maybe, I'm not sure. Something smoked. So I'm going to try desoldering that, testing this buck converter, then I'm going to solder that back onto the buck converter, back onto the Bluetooth board, and then test those two together on a separate power supply, isolated from all this. And then I'm going to test if that works, then I know that this circuit board, the voltage dividers, are awful if I know they're not delivering enough current. So I don't like them anyways, they get too hot and they're terrible design really on my part. So I'm going to potentially redo this board, but we'll see. We'll test these and then I might completely rebuild this because these aren't very good, they can't really deliver the current. I had to put this little LM317T on there because it delivers more current for the amplifier, the TDA2030 anyways, which is what some of these resistors were originally for. But I thought, well, I keep them for a fan, but you know, if it doesn't work then there's no point in having them, so I might just rebuild this whole board. So we'll see. So while waiting for the soldering iron to heat up, I've tested the voltage and current I can get out of these voltage dividers. It's only 10 volts at 40 milliamps coming out of the voltage divider for the buck converter, because I didn't want that trying to limit loads and loads of voltage and current from the main 24 volts. So I think that's probably the problem. I think I need quite a lot more current for this, because then we're losing some in this anyways, so which obviously we want to, but we don't want to limit the current that much. So I'm only getting about 10 milliamps on the output of this after measuring this as well. So 10 milliamps at 5 volts. I don't know if that's enough to run the Bluetooth speaker board. I don't know, probably not. So I think we'll test it in a minute and see. Yeah, it would appear I'm being stupid. The buck converter and the Bluetooth speaker module draw 111 milliamps when it's providing a speaker with an audio signal. So this module thing I made is kind of obsolete because, well, none of it's needed really. None of these resistors are needed. All I need is of this is the fuses, the rectifier, and a few capacitors, and maybe some filtering and smoothing just to stuff, you know. Maybe that's probably not really needed, but I'll keep it anyways, the DGT. So I'm probably going to rebuild this circuit on another perf board and get rid of all the crap I don't need, and then that will work. That will be the straight off 24 volts. That's working straight off 24 volts anyways. And then I've got a voltage divider underneath which powers that amplifier, which is running on 12 volts, and this one's outputting 16 volts for the TDA2030, which I believe is about 18 volts it'll go bang at. So I'm running that at about the right power supply. So hopefully it'll work this time and not produce smoke. Not that I know where that came from. plan now is to fill this jam jar with oil and resistors. So I'm going to smack these resistors in here, put the lid on, and then probably drill a hole in the top, fill it with oil, and have the wires coming out all nicely. And then I can turn it upside down and it will fit inside our lovely box right there, and hopefully it won't short out or explode or anything bad happen, or leak oil, which will probably be even worse than anything really, because I don't want oil going everywhere. Hence this seal, which I'm going to try to make. It leaks water, this jam jar, if you fill it up and give it a shake, so I'm not sure how successful this is going to be, but we'll give it a go and see. Alright, so this is what I've made. It's the resistor jam jar oil creation. Question is, will it hold oil when it's upside down? I don't think it will, but we'll see. Hopefully it does, because I think I screwed the lid up and it didn't glue it properly when I screwed it up. But we'll see. We'll see. I put a blowtorch around it, around the outside again, so hopefully it'll melt the glue and work, but like I say, I'll have to go and test it and see. So after testing, we have oil and it doesn't seem to leak. Put a little rubber grommet around the bolt and it doesn't seem to leak. It's got oil all around the outside at the minute from where I've poured it in and lost a bit, but it doesn't seem to leak. And it will be sitting upside down inside the box. A small air bubble. That shouldn't matter if it's on the top here. If it's the other way up, it will matter because the lid's steel, so it'll probably arc. But like that, it should be fine. There's only a tiny bubble, and then yeah, get some connections on the top insulated, and then it should be good. And make something that'll. I'm gonna have to make something that it can sit on, and that will bolt it down. But overall, not a bad attempt. I'm going to put it in a container upside down for 24 hours, and that way I'll be able to see if it's got a small leak on it, because if it leaks, obviously I'll have a big problem. So if I leave it in a container like that, then I'll see if it has got a tiny leak anywhere. It should be fairly obvious, but I don't think it has. Okay, so first test. That's not good. It should be playing sound now. Sounds like a jet engine. Oh, hang on. Helps if you turn the power supply on. There we are. Max volume set. So, as you can hear in the videos, we're getting lots and lots of AC, I think that's what that is, AC coming through from this transformer. Because my capacitor, that is the only capacitor that does the side of the transformer for the Royer oscillators. So I think I need a bigger capacitor, so I've got a 100 volt one here, which is pretty big, which I'm going to put in, and it's annoying because I don't really have much space, as you can see. So if I put it over here, hopefully, dump that over there somewhere, then hopefully it will fix our problems. And then for good measure, I'm going to put this smaller one in, which there's the values, on the other side of the circuit, which does all the audio amplification. I'm going to put that one in there, and then hopefully we won't have that horrible sound that's coming through, and hopefully it will work. The potentiometer I made, it's more of a switch with a load of resistors dumped around it, as you can kind of see there. They're quite hard to make, to be fair. So yeah, we'll see how that goes. Okay, so I've added that capacitor and turned it on. It didn't make a massive difference. So I'm about to test it with that smaller capacitor that I added, and we'll see. So I just need to flick the switch, and sure enough, well, I mean, it sounds awful. Okay, so it would seem that by adding that capacitor it made it better, but it's not fixed. I need to add a bigger capacitor, I think. I need to make a really big one even bigger. Right, added another little tiny capacitor as well, so see if that does anything. Fuck all, apparently. Yeah, so basically this potentiometer is going to need changing because the values are wrong, and because it was meant for the original circuit board. So I'm going to have to take it out without it breaking, and then try and change the resistors, or maybe even rebuild the whole thing. But it's because it was actually for the version 1 main circuit board, and obviously this one's slightly different, so that's why it sounds so terrible. So basically this has the wrong resistor values, so I'm going to rebuild it. I'm going to redesign it actually, I think. I'm not going to use this old one. I think I'm going to build another one with a load of these old PCBs. But I'm going to keep the same middle piece from the potentiometer. So I use that, and then I'm going to rebuild the rest of it. That's not good. So I've changed the potentiometer, and I've put this one on, and I've put the right values on there so it will actually affect how it sounds. As you can see, so that'll be, I can see that resistor slightly damaged there obviously, but it shouldn't matter, not for what this is going to be used for. It won't need that, and it won't need to be that big anyways, but so it should be fine. And then that's going to go down in there, and that will fit nicely where the other one was. And then I'm going to put the same dial on it. I'm going to put this on there because it looks good. And then I've got to add a discharge resistor for the capacitor bank over there, because when it's actually discharged for once. Every time I've tested that, that's been charged up. These resistors seem to work fine, so I'm going to put that in there now, and then hopefully that'll be this project done. I had a little burn up there, didn't I? Oh well, we'll see. So the reason the AC humming that was coming through in the arc was so bad is because the audio amplifier side didn't have a big enough capacitor bank to filter out the AC rippling. So now I've added a bigger capacitor, one of the big ones I've separated, as you can see, and that's now, that end one is now filtering for the audio amplifier side. And because the power supply wasn't smooth enough, I think the amplifier was amplifying the ripple with the audio. In total, this project took me about 1.5 years to complete, with large gaps of course, because I got stuck at bits on how to solve problems. I wanted this project to be as reliable as possible, and I think that's what I've achieved with this design. It seems to work okay. Doesn't sound as good as I wanted, and there's a lot of improvements I would like to make on a next version, but for the time being this is quite good and I'm quite happy with it. I'm quite pleased with the way it turned out. There's not a lot I would fault it with, apart from, of course, the extreme bassy sound that it has with it. I think I would probably make it less bassy in the next version, and I'd like to make the arc bigger, but of course that requires a lot more engineering and a lot more skill that I don't have at the minute. I'd like to make a bigger version, quite significantly bigger, but this is alright for the time being. Thank you for watching all the way through this video. If you have managed to get all the way through it, it's quite long by now. If you have any questions or queries, put them in the comments. Like if you like the video, if not, don't bother.